Let's learn about Shockley diode, and under that we're going to cover the introduction, working of Shockley diode, construction of Shockley diode, VI characters of Shockley diode, advantage and disadvantage, and the applications.
Definition: Shockley diode is a four-layer PNP device which conducts when it is forward biased and stops conducting when it is reverse biased. The major difference between the conventional diode and the Shockley diode is it starts conducting when the forward voltage exceeds breakover voltage. It was invented by the William Bradford Shockley, and that's why it named after its inventor. Shockley diode is not widely available commercially. Still, it forms the backbone of devices like diode SCR. It operates in two stages, either on or off. Thus, it is used as a switching device. It is also called PNP diode because of its construction architecture. It is a two-terminal device, that's why it is categorized as diode. Shockley diode working principle. Named after its inventor, a Shockley diode is a PNP device having two terminals as shown in figure 1. This device acts as a switch and consists of four alternative p-type and n-type layers in a single crystal. The various layers are labeled as P1, N1, P2 and N2 for identification. Since a p-region adjustment to an n-region may be considered a junction diode, the Shockley diode is equivalent to the three junction diode connected in a series as shown in figure 2. The symbol of Shockley diode is shown in figure number 3. Since Shockley diode is forward biased, anode is positive with respect to cathode, diodes 1 and 3 would be the forward bias while diode 2 would be reverse bias. Since diode 2 offers very high resistance being reverse bias and the three junctions are in series, the Shockley diode presents a high resistance. As the forward voltage increases, the reverse bias across D2 is also increased. At some forward voltage called the breakover voltage VBO, reverse breakdown voltage of D2 occurs. Since this breakdown results in reduced resistance, the Shockley diode presents a very low resistance. From now onwards, the Shockley diode behaves as a conventional forward bias diode, the forward current being determined by the applied voltage and external load resistance. When Shockley diode is reverse biased, anode is negative with respect to cathode. Diodes 1 and 3 would be reverse biased while diode 2 would be forward biased. If reverse voltage is increased sufficiently, the reverse voltage breakdown point A in above figure of Shockley diode is reached. At this point, diodes 1 and 3 would go into the reverse voltage breakdown. The reverse current flowing through them would rise rapidly and the heat produced by this current flow could ruin the entire device. For this reason, Shockley diode never be operated with a reverse voltage sufficient to reach the reverse voltage breakdown. Construction of Shockley diode. It is formed by sandwiching four layers of semiconductor p-type, n-type, p-type and one more n-type. Three junctions are formed due to the emerging of four layers together. The construction and the circuit symbol are described in the below diagram. The construction of Shockley diode can be understood by the two transistor model. The four layers constitute internally two transistors T1 and T2 connected together. The emitter base junction of transistor 1 is junction 1. The common connected base and collector of transistor 1 T1 and T2 respectively constitute junction 2. The base emitter junction of T2 is junction 3. When the diode is to be operated in forward biasing, then junction 1 and junction 3 are forward bias and junction 2 is reverse bias. The Shockley diode is operated in the forward bias mode only. When junction 1 and junction 3 are reverse bias, the junction 3 is forward bias and the device start operating in reverse bias mode. But it is operated in reverse bias and the voltage exceeds the breakdown voltage, the diode gets damaged. VI characteristics of Shockley diode. As discussed above, when the junction 1 and junction 3 are forward biased, the current in the diode starts increasing. Thus, it can be seen from the characteristics curve that above breakover voltage current is increasing significantly. And when current attains a value equal to holding current value, the Shockley diode is in on stage. When junction 2 is forward bias and junction 1 and junction 3 is reverse bias, the diode operates in reverse biased mode, due to which reverse current start increasing, and if the reverse voltage exceeds reverse breakdown voltage, extensive heat is produced due to the large magnitude of reverse current. This leads to the destruction of diode. Thus, it is never operated in reverse bias mode. Advantages and disadvantages of using the Shockley diode. Firstly, the advantages of Shockley diode. These diodes have a high switching speed. It can perform more as compared to a transistor because its construction includes the two transistors that are connected through a common terminal. It gets leached into the on stage. Forward voltage drop is low, so power dissipation is also low. Reverse voltage can also block easily. It can be protected by a fuse from the overcurrent. Now let me go with the disadvantages of using the Shockley diode. Its construction is somewhat difficult because it uses 4 semiconductor materials layers. It conducts only in a single direction. It can switch on suddenly because of the red effect. No sample to turn off. It cannot control at a first speed. It does not include any controlling terminal. There is no control above the forward breakdown voltage.
Shockley diodes are used mainly for switching applications. The two main important applications of Shockley diodes are relaxation oscillator and triggering switch, as discussed below. First, as relaxation oscillator. The below figure shows the relaxation oscillator circuit using a Shockley diode. In this, the diode is connected across the capacitor power with the power supply battery. When the battery voltage is applied to the circuit, the capacitor charges through a resistor R. When the applied voltage or voltage across the capacitor is more than the breakover voltage of Shockley diode, it becomes turned on and acts as a switch. This causes rapidly to discharge the capacitor through the diode, and when the current through the diode is less than the holding current of the diode becomes turned off and capacitor charges again. The voltage across the capacitor is shown below figure, where the voltage at the reference is more than 0 volt because the capacitor will not discharge completely. Number 2, as trigger switch. Most common application of Shockley diode are switching circuit to turn on the SCR. In the below circuit, SCR is triggered by the Shockley diode. The resistive and the capacitor RC network is fed with a DC supply which drives the Shockley diode. When the VCD is applied, Shockley is forward biased and also capacitor starts charging through the resistance. When the charging voltage of the capacitor reaches the breakover voltage of the diode starts conducting and the capacitor starts discharging through the diode. This conduction of Shockley diode drives the SCR into turn-on state. Then the buzzer gives an alarm. Once the SCR is turned on, it will remain in the latching or on state until the power is removed or commutation technique applies to CRs. So, There is no effect of the gate or Shockley diode circuit to make SCR off. However, the triggering time of SCR is controlled by selecting proper values of capacitor and resistor.